Hey guys, another day, another video. So, before we get started, quick update on the channel. So, it turns out I'm going to be making a series of videos for the Solana guys. These videos are going to show up on their channel and not mine. So, for a while, I think the videos on my channel are going to be kind of coming in maybe sporadically. I do intend to keep going. Eventually, I'll probably end up doing something with NFTs just because it's so hot and stuff like that. But just wanted to give you a quick heads up. And today's video. So today's video is the third in the series. So the first video was the introduction. The second was the how to connect to a wallet and send money. So this video is going to be basically a simple chatting application. So as you can see here, we have two windows on different browsers. I needed to do that so that they can connect to different wallets. So you have the wallet per each browser up here on the top. And then you have any ongoing messages that are already here between the two. And then, and I'll explain this as we move forward, but there are separate dedicated accounts for the actual messages to be stored into. So my chat message is, of course, this specific guy's account for holding chat messages, and then the destination would be this guy right here, and vice versa. So I had already sent a message for testing. So if I send another message, I have to approve it because it's a transaction, so there's a small cost. So the wallet forces me to approve it. And then, as I mentioned last time, all of these messages are being saved to Arweave because, as you can imagine, over time, this could be a lot of data. So you don't want to have to pay rent on this to Solana or hold a lot of staked LAMP ports in the account. So that's what's going on there. And then you do need to refresh manually because I haven't gotten around to creating some kind of polling mechanism that will auto refresh the messages. But as you can see, this works fine. And just be aware, this is strictly a demo sample application. In no way am I suggesting that this is the way that you should create your app. Obviously, if every time you send a message you get alerted and then you have to approve it in order to send it, it would be a very cumbersome chat application. But there's actually a lot of complexity here. There's a lot of things you have to know about, especially serialization and deserialization and the mechanics of interacting between Solana and Arweave, or really any other decentralized data store. So if you went IPFS, most of the issues that I'm about to show you in this video would have to be resolved in similar ways over there as well. So this is strictly about learning more in depth how Solana works and also throwing in Arweave in there as well. So let's get started. Okay, so as mentioned, we are going to be integrating Solana and Arweave. So I'm assuming you've watched the previous videos and you've set up your development environment. You've got Node, you've got the Solana CLI, you've got the local runtime running. I'm currently running the local version of the network. Of course, you can run on DevNet if you don't want to run locally. This is my logging screen. This is my regular test validator execution screen. So I'm assuming you guys have set everything up for as per the previous videos. So in today's video, we're going to need the test weave Docker installed. So basically what this is it's a project on GitHub, so you would have to clone it. Let me see if I can get a better, okay. So you would have to clone it, right? And then in the command line, let me just show you what it looks like. So you would clone the project. In the command line, you would execute the project. The execute command is this right here, right? So this is a Docker project, so that would mean you need to install Docker first, right? Set up your Docker environment first, and then execute the command to get this particular project up and running. I don't show how to install in my videos. I think it's a waste of time. I'm sure you guys are smart enough to figure that out. So go ahead and take care of that first. And then when you're ready, you can come back and we'll take a look at the code. So assuming you've done that, this is the project that we're going to build. And I'm going to make, just like the previous two videos, I'm going to make this source code available. I'm not going to make it available immediately. I'm going to wait until I get a few hundred views or so first on the video, and then I'll make it available. But basically, this is of course, an NPM project. It's a Create React application project, slightly modified. The dependencies are going to be similar to what we had in the second video, but of course, we're adding the Arweave. And we're also adding the test Arweave SDK. The Arweave project that I showed you will not install this, so you need to install this separately. So make sure you're having all of the dependencies that you see here. And then I created a separate folder called Program to put in the actual Rust-based smart contract. And we're going to review this project starting here first so that we can understand what exactly we're going to have to pass into the smart contract. So we're going to do that first, but I wanted to give you an overview of the application structure on the client side. So just again, this is a sample project. Don't write code like this. I'm just showing you some possibilities here. But basically, in order to make things easier for you guys to find, whatever is related to Arweave, I've put into source Arweave. So anything that you need in terms of Arweave, just look in here and you'll find it in here. Anything specific to Solana, I put into this Solana folder. So for example, interacting with the wallet, I'm using Solay.io. You can use something else if you want. And of course, we're running locally. Accessing the program itself, I have the program ID right here. Of course, this would be replaced by your own program ID, and so on and so forth. And then anything specific to React and component building, I have in this component folder, unless it's one of the root components, which would be app or index right here. Okay, so let's get started with the code. As mentioned, we're going to start with the program itself. Again, program is Solana speak for smart contract. So up here, we just have our imports, the dependencies that we need. And then again, if you recall from the prior video, we have a specific type. So this is going to be the schema of our data in our account. In this case, for demo purposes, I wanted to do something a little bit more complicated, so I'll explain what's going on here. So this represents a chat message instance. So because we are not saving this time around, unlike our first video, we're not saving the actual chat message inside of Solana. We're saving it inside of Arweave. What I'm putting into Solana is basically a pointer of the transaction ID, the Arweave transaction ID, and I'm saving that into Solana as a record that points back to Arweave. Okay, and then additionally, I'm just putting a timestamp just for record, keeping purposes, metadata purposes. So just to clarify, this is a string in order to be able to accept milliseconds from the client side, because we're going to be using React, which of course is using JavaScript, and that is going to be passing in a milliseconds timestamp. You can convert a date object in JavaScript into milliseconds starting from 1970 UTC time. So for ease of serialization, deserialization, I'm just taking advantage of that fact. And this is going to be our actual chat object instance. These traits being implemented here are the thing that give the ability to deserialize and serialize our object instances. Now, the complexity, or part of the complexity that you're going to see here, is that because we're sending in multiple messages, right, over time, the data that's actually going to be stored in the account is going to be an array of these. And you're going to see that that actually has a fair amount of complexity to deserialize and serialize, especially when we look at the client-side code later. So just be aware of that. And then what is all of this busyness right here? So if you saw my previous videos, you know that currently the account data in Solana is not resizable. So they're going to make it resizable in the future, but currently it's just an array that cannot be changed according to Solana. So what I'm doing is I'm allowing for certain placeholder values, dummy values, for the archive ID and the created on ID. So I need to get some dummy values in there so that we can have the right sizes for serialization and sizing purposes, or else you end up getting a bunch of failures and error messages and stuff like that. So then these two functions are going to be for initialization of our data, and I'm going to get more depth into what that means specifically. But basically, as you can see here, we're creating object instances with the dummy values. And then because, as I said, the actual data is an array of these object instances, for testing purposes, I'm just going to have up to 20 in there. And I'm just going to initialize, 20 records for testing purposes. So then if we scroll down more, we see the entry point to our actual smart contract, which is a Rust function. And then as before, we have a bunch of parameters that we put in. The main one is the data that is going in as parameters to our account. So some of this code is like from the previous video, so I'm not going to explain it. But if we drill down, here's where the meat of the code starts. So what's going on here is we take our chat message object and then we deserialize, we try to deserialize the instruction data, which comes in as a byte array, right? So we have to deserialize it so that we can get the actual object instance out of it, right? So we're doing like an encode decode scenario, right? And then if this should fail, then we're logging it, and then we're sending back whatever the error message is. So technically Rust doesn't have exceptions, but anyway, this is what the error object that's being sent out is about. So then once I get it, I want to log it just to make sure that I'm getting what I expect. Most of these log messages, once you're finished testing, you should probably get rid of them because even logging has a computation cost. And as I mentioned in the previous video, you're limited in terms of how many compute units you have to execute. And again, that's in order to protect the network. So let me get rid of this thing so you can see more of the code. So then fine, what are we doing here? So now we want to gain access to the data in our account so that we can update it, right? So how do we do that? Well, as I mentioned, the data in the account itself is actually an array of chat message records, right? So trying to call deserialization on an array of chat message records doesn't work. So you have to use a vector, which is effectively the same thing, but it's a dynamic array of chat message records. And then from that, you can deserialize an array of chat message records. So this is so that it maps one-to-one. It's apples to apples. So then if I do that, one of two things might happen. It might succeed or it might fail, right? So here I'm using match, which is the switch, which is Rust's way of doing a switch statement, right? So if this succeeds, which is represented by the enum OK, then I can get back and return the unwrapped data, the actual stuff that we care about, right? So the vector array, the dynamic array of chat messages, right? If it fails, as represented by this enum then I'm going to get back the actual error. Now, the error itself inside of an could be any error type that you want, as long as it implements error. But in this case, I know that I'm using Borscht in order to deserialize, so I know that it's a certain type of error. So I'm going to check the error kind, right? To see if it's an invalid data. And then if it is, I know that this is the first time ever that this smart contract was run, and therefore this data will not actually have any vectors of chat messages inside of it. Because when you first create an account's data from the client side with the system program.create account calls, it will size it and initialize it, but it will initialize it as an array of zeros. So obviously that would never deserialize into a vector of chat messages. So the attempt, again, on the very first try is going to fail. And assuming no other error happened, then it would drop into this code right here. So then I would take the opportunity to run our initializer function, the one that I just showed you before. And it's going to go ahead and create 20 records of chat messages. And they're all going to have that filler text of zeros so that we can have the right sizing and we don't have any errors during serialization or deserialization. Now, if something weird should happen that we're not expecting, then we're just going to panic, which is the same thing as throwing an exception in Rust. And the reason why we're going to panic, although in most instances in Rust, you don't want to panic and you don't want to do, anything that would cause a panic. But in this case, because we're running a smart contract and it could potentially be dealing with, a lot of money, we don't want to run into a situation where we end up losing that money, either through a bug, because we just kept our code continuing when it shouldn't have, or some other issue. So in this case, it's one of the rare instances where you want to actually panic, right? All right, so moving right along, let's assume everything went well. We initialized, so we're in this state where we don't have any valid data, but the schema of our data, the structure of our data is at least valid with those 0 values. So then what are we going to do next? So what we're going to do next is we're going to take that resultant deserialized data from the account, and we're going to make it iterable. And in Rust, anything that is iterable is also mutable. And then we're going to take the position of it based upon some code. And what does this mean, position? The position, and this is a terrible name, but the position is the index of the array record. Okay, so the element index of the specific record that we found based upon some logic right here. Okay, so this pipe P is the beginning of a closure in Rust, right? So an anonymous function. So in here we check, okay, so the element itself, its archive ID, is it equal to the dummy text value? So in other words, what I'm trying to do here is I'm assuming that if I'm here, I've already initialized the records in here to dummy values. And furthermore, this may be the second, third, fourth, etc. running of my program here. So I don't know which time I am running this program. It could have been once, it could have been the very first time, it could have been 10 times, whatever, right? So what I need to do in order to insert the data correctly is I need to find the very first instance of a dummy record so that I can modify the dummy values that are in here. And I'm going to get into more detail about why we need dummy values. But so then if I am doing this for the very first time, as you can imagine, then this index value would be 0, right? Because this, as soon as it finds one record, even though we have 20 in here, as soon as it finds one record, it drops out immediately, okay? And so if this is the first time I'm running, this would be equal to 0. If this is the second time I'm running, then this would be equal to 1, and then 2, and then 3, and so on and so forth, right? And again, I'm doing a hard unwrap, potentially causing a panic, because if this fails, I don't want to continue, right? I want to die immediately. So now, why do I have these odd looking dummy records, and why do I, even need this stuff? And then why do I need to fill in or overwrite these dummy records? Well, actually, you know what? Before I explain that, let's just see the rest of the code, what it's doing. So once I get the index, I'm able to find the specific element in this array of chat messages that I want to overwrite, right? So then I'm able to take that instruction data message that we just deserialized up here, right? And I'm able to set it right here, right? Because it's the only record that I need to set. I don't need to touch anything else, right? So then once I do that, now I want to encode, I want to serialize this array of chat messages, right? Dynamic array of chat messages. And I want to set it to my variable so that I can put it back into the account's data, right? So as I mentioned before, the mechanics of doing this is not trivial. So like I said, although you never want to build an app like this, knowing just the various activities and the calls that are needed is going to help you out, regardless of what app you need to create later on. So we got now our completed, updated vector record in the form expected by Solana's account data. So that's what we have right here. Here is just another log message, so not a big deal. I just want to check that the particular element I care about has been updated correctly. So then here is where we want to explain why we have these dummy records and why we're updating them instead of, just creating a blank new object instance and adding whatever data we need to add. So if you look down here, you can see this range element right here, right? So this is taking our updated data that we just created up here, getting its length, and creating a range for our array out of it. And range means start from here and end to here. That's the part that I'm interested in. That's what a range is, right? So then this data is just a short, a shortened name version of our currently unmodified account data, meaning our existing account data before we change it. So then we borrow it as a mutable because you have to be explicit in Rust. So we do that. And then we say in here, give me the data from here to here, which is the same thing as our updated data's length, right? So as you can see, when we finally update the account's data, not only does the correct schema, the correct data type have to go in there, right, for later purposes when we read the data, when we change the data, etc., but it has to be exactly the same size, or else this will fail. Okay? So therefore, because so technically the Arweave transaction IDs don't change in size. However, the created on IDs do change in size because, like I said, they're milliseconds. So earlier in time is less and future in time is more. So they do change, but we cannot have changing data put in here because then the length of the updated data and the length of the data in the account record would be different, and then this attempted insertion would fail. Okay, and this is similar to the same thing that we learned about in our first video, right? Except with a more complicated schema. So although in this case, this may not apply to your app because you're not using Arweave or you're not using, their transaction IDs, but regardless, you're using something and you're inputting something, and more than likely that record is not always exactly the same length. So you need to, handle that in some way. And the way that I figured out is this way. Although if you can do it a different way and still maintain equal lengths, then that'll work as well. But that's what this sort of insanity is about. So then here, I just want to confirm again that everything happened successfully inside of the actual data post the save. So that's what this logging message is about. And yeah, that's it. So now here's the thing. If I wrote this code by hand, obviously I need to test it, right? I'm not going to just write something this complicated and it'll just work on the first try. That's almost impossible, right? So I need to test this. But would I want to create an entire, client-side application just in order to test my program? Obviously not, right? So in this video, we're going to introduce the topic of testing the smart contracts. So that's what I've created here. And this is based off of their Hello World sample. So it's pretty easy to get started, right? Now, in Rust, you have to label it with this attribute annotation. And then you create a module test. Super means the current module, which is this file right here, and then some necessary dependencies. And then this is going to be our first and only test right here. Okay, so this will get you the current program ID, right? The current accounts, running accounts ID. This is the key. I don't know if we're using this. Oh yeah, we are using it. Okay. So this is the key for the account. And then we have the LAN ports, which I guess for testing we don't need. But here, the most important part, I'm doing the initialization again to get the messages, right? And I'll show you in just a moment. Okay, right here. So, so I initialize so that I can create the account with a pre-initialized set of data. Okay. And then once I do that, I pretend that I have an instruction data that I pass in from the client, right? So I fill in the values. Again, these lengths are the correct lengths. This is 43 and this is 16. And that's why you see the prefix of 3 zeros. I had to fill in because this is only length 13. And then I create an instance of the chat message. I serialize it. All right, IntelliSense is not working. So I serialize it, right? So it gives me an array in here. And then I take the accounts and I pass them into our call to the actual smart contract. So you have, again, the program ID, the accounts, and then the fake instructions that I just created right here. Now, once I do that, I want to confirm that the data got put in as expected. So in this case, because we created our account fresh, we create our account fresh every time we run this particular test, right? We know that after our smart contract runs, that we just need to look at the first element. Okay, so what I'm doing here is I'm taking that first account, and this is specific to our particular smart contract. Okay, depending on the logic of your smart contract, it may not be the first account, correct? It may be the second, the third, whatever. But in our case, it's just the first account. So we're going to borrow it again. We're going to deserialize it again. And then we're going to get that. It would have been an array of chat messages, but again, we just care about the first one, right? So it's a single chat message. And then we're going to take that chat message and we're going to look at, or we're going to test the values of the archive ID and the created on, right? And the way that we're doing that is we're taking the initial value, the test value that we hard coded up here, right? So archive ID and then created on. And then we're going to compare against what was changed or updated by our smart contract. So we're going to make sure that that exact set of data was passed in by our smart contract into our account data, right? So we check these two are equal, and then we test that this is true. So there is no straightforward way to assert this line right here. So I'm testing it right here with Rust, and then I'm asserting that this test is true using assert, right? So I'm asserting that this value in here and this value in here are the same value, right? So if I wanted to check that this is false, in order for this assert equal to be true or correct, this would have to be false. Okay, so here I do the archive ID and here I do the test created on ID or test created on field. And then let's see if this works. So in here, I'm going to do this. Now, where did I get this script from, or where did I get this command from? So in the test code, once I make it available, you're going to see some pre-built mini scripts, basically. So the one that we care about is right here, right? So we're going to use cargo. We're going to use BPF because that's the binary format that Solana is using. And we're going to use the manifest that is in our program directory, this guy right here, right? And we're going to force tests to run, which again is this stuff right here. And that's what's going to run down here. Now the other stuff that you see is I just created a short little script to help you generate a wallet once you're ready to try it out in production. You're going to need a wallet. So I just created a script to make it easy for you to do that. So that's what these guys are for. And then all of these are the built-in create React app scripts. Now the reason why I put this environment variable prefix in here to change from the default port of 3000 to 3001 is because the TestWeave Docker image that runs our test instance of the Arweave runtime, the Arweave network, is on port 3000. So obviously that's a clash. So doing this will tell React to run on port 3001. So that's what that's about. All right. So if we run this script, hopefully our tests will be successful. Okay, so our tests are successful, right? So we've prevented ourselves from having to build our entire client just to check our smart contract before we're actually ready. Because obviously when we test, we're going to test and it's going to fail, and then we're going to test again and it's going to fail, and we're going to add more code and that's going to fail, and then so on and so forth. There's a lot of iteration that's going to happen during testing. So for that reason, and also just for security reasons, making sure that your smart contracts are doing exactly what they're supposed to do. And even when they get refactored, modified in some way, the tests are still passing. Otherwise, you're going in, seeing what the problem is, updating the tests or updating the code, whatever the case may be. This is super, super important to do. You never want to have any smart contracts that you deploy into production without a whole series of tests backing them up, confirming all of your logic. If your app becomes successful and you're dealing with people's money, potentially millions and millions of dollars, you don't want bugs, you don't want security holes. That's the last thing that you want. All right, so let's get started on the client side code. And this video is focused on Solana and then of course Arweave. So I'm not gonna, spend a lot of time explaining React and React related stuff. So let's just get an overview of what we're doing here. So ignore this. I was just messing around with Apollo. We're not going to use it. So basically what's going on is, like the second video, we have to initialize our wallet, and I'm reusing a lot of that code. So if you don't know what I'm talking about, please watch the second video, because that's where I show sort of the ins and outs of attaching to a wallet and sending money and signing transactions and stuff like that. So what I do is I initialize the wallet on first load, and then once that initialization is successful, I get the wallet object back and I get the connection to the particular cluster that we want to be on. So then once I do that, what I do is I create a chat message account. So what the heck does that mean? So when you subscribe to a wallet, you create a wallet account, it will create one single address for you. And of course you can add multiple addresses on top of that, but none of those addresses are going to have any data available to them. The data is going to be 0. So this is deliberate because in Solana, data costs money. Either you have to pay rent for having any amount of any arbitrary data, or if you like, you can stake a certain amount of land ports and become rent exempt. But of course, there is an opportunity cost, because you can't then take that money and do something else like invest it elsewhere. So because of that, I'm assuming the wallet people will create you accounts that have data of 0, meaning empty. So we can't put any records in there, any of our chat messages in there, because currently we can't resize the accounts, the data inside of accounts. This feature is coming in the future, but it's presently not available. So what I'm doing here is I created this function that will, if needed, create a new account on behalf of the user, which will have a certain amount of land ports so that it doesn't get charged rent, and will have a certain, as indicated here, a certain size of the account so that we can fit our 20 messages. And I'm going to show you what this implementation looks like in a few minutes. But once that account is created or confirmed to already be existing, then on the callback, we're going to set the chat address for display on the UI. And then we're going to try and get back any messages that are available in the in those accounts, related accounts. So that would be my account right here. and then the destination chat address, which would be the this guy right here, right? So he would have the inverse showing up on his screen. So that's what this is determined to do. And the implementation is to get the history of received messages and the history of sent messages per the addresses that are related, and then to get an array of objects specific to that and set local state. So we're going to get into the implementations of all of these functions right now. So as I said before, to make things easier for you guys, I'm going to put everything related to Solana, specific to Solana, in the Solana folder, so you don't have to hunt around. And I'm going to make this source code available after I get a couple of hundred views on the video. So this function is going to need a connection. This connection represents the specific cluster that you're going to, the current user's wallet, the space of the account's data that we're going to allocate for. Again, the bigger the space, the bigger the rent, or the bigger the rent exemption. If an account, if for some reason while you're testing you need to reset, meaning even though you've created an account already, you just want to create a new one so you don't have any of the older data in there, then I just provided this convenience parameter that allows you to do that, but it's defaulted to false. So in here, we skip that. And then we go and we try to find if an existing chat account has already been created. And we base that upon the user's main wallet address. So the wallet address is the key, and then the value of the chat account's public address is the value of what's being stored in local storage. So this means that after you run this, you create the chat account. Every time you refresh this screen, for whatever reason, you don't have to go through the process of recreating the chat account all over again. It will just go to local storage, use the user's wallet address, find the matching chat account, and then, assuming that exists, then it'll go ahead and just return the value. Okay. Now, if any of this fails or you want to do a reset, then it goes through the process of actually creating the account. So a lot of this stuff I did go over in the previous videos. You might want to take a look at that because I'm going to kind of burn through all of this stuff pretty quickly. So in this case, we are going to create the new chat account based on the user's wallet address. So we need a seed in order to do that. So this is our seed. This says who's going to pay for this particular transaction, how much LAMP ports this new account is going to get. Again, we are using rent exemption because I prefer it over paying rent. Either way, you need some money in the account because if your LAMP ports go to 0, on the next epoch, the system will try to collect rent. And if you have no money, it will basically disable your account and you will never be able to access it again. So the size of your account and then the program ID that is allowed access into the account. Then we have the previous stuff about how to create a transaction, set up the payer, stuff like that. Creating the signature for the transaction. Some of this APIs has gotten updated recently. So even if you say started working with the Web3.js APIs maybe about a month and a half or so ago. A lot of the APIs have changed in terms of the implicitness of signing the transactions and setting the payer and stuff like that, and the previous block cache. So now it has to be done explicitly, whereas in the past it was done implicitly. So you definitely want to check that out in the code later. So once I create my new account, so that I don't have to refresh it every time, again, I save it into my local storage. That is the storage inside of my browser specific to a particular URL. This is the key. This is the value that I'm storing, and then I return the key. All right, so then we go in here, and then we see how once we've set certain messages, as I said before in the beginning of this video, we're not actually putting the real data, in this case the messages and the created on timestamp inside of Solana. We're just going to be basically putting in pointers and metadata that point to Arweave, and then the real data, quote unquote, is going to be inside of Arweave. So in order to retrieve the data, we have to do the reverse. So we have to go into Solana, we have to find those pointers, those transaction IDs, and then we have to point back and query into Arweave to get the actual data back. So if we go into this function, get message received history. So I created a helper function because I realized that get message received history right here and get message sent history are using 90% of the same code. So I created a single helper that each of these guys would call. And this helper is doing all of the actual work. So what is it doing? It's getting the specific address that we're going to be pulling the records from. Right? So that's here. I should have renamed this to something general, but I think you get the message. So I get that account because, again, data lives inside of accounts. The main element inside of Solana is an account. And then assuming I get something back, I go here. If I don't, I throw an exception and immediately drop out. Where is it? I get that data back, okay? But before I can actually make use of that data, I have to convert it into an instance of the actual type. So as you can see here, as I hover over, the data is in the form of a buffer, a memory buffer, like a blob, basically, a binary blob, right? So if we go up here, you can see that our actual types for our data is not a blob, is not an array of U8s or some other binary format. It's actually a JavaScript type, right? Because that's what we need in order to be able to reference its members and access the data, right? So if you look at this class definition right here, you can see that it's pretty much similar to our struct representation inside of the smart contract, right? Now in Rust, it's a struct because there are no classes in Rust, but effectively we're trying to map this class from the client side to this struct object on the program side, right? Which is why we need all of this deserialization code that you just saw, and I'm gonna get more deeply into in a moment. So not only do we need the type, we also need the schema, and I explained this in the previous videos. So if you don't know what I'm talking about, please take a look at those. And that's the form that we need to do a decode into, right? So that we can actually call into it and access its members. So that is what all of this busy code is about. Now, initially, to tell you the truth, I was trying to use Borscht because there is a deserializer inside of Borscht. But Borscht is not documented like at all. And I couldn't figure out, how to do it. So then I had to resort to using buffer layout right here. And by the way, the examples inside of the examples from Solana, the Solana team, like Hello World and all of that stuff, were initially using buffer layout, but then they switched to Borscht. But the issue is, in our case, we're now dealing with an array of items as opposed to a single object instance like we were in the previous Hello World example project. So Borscht, I couldn't find a way to deserialize an array of that chat message type. I don't know if it's not doable, or I was just doing something wrong, but basically it wasn't working. So what I've done here is I've used buffer layout. So what is buffer layout? Buffer layout is a tool inside of JavaScript, very similar to Borscht, that will help you do a mapping from one programming language binary format into JavaScript. That's basically the same thing as Borscht, but again, it wasn't working. So in this case, this code looks very complicated, but it's actually not that bad. So what I'm doing is, ultimately, I want to create a struct that represents the object coming into our set accounts data, right? So I do that by acknowledging each of the two variables, the member variables, archive ID created on, acknowledging the type that they are. So this is a C string. This is an array of characters as presented by the C language, but it happens to work in Rust as well. Now, how do I say this? It's not this straightforward to simply type that out, give the member name, and then create our variable, because each of these binary formats have their own way of actually spacing out the data in the stack or whatever the memory that they're using is. So on top of that, you're going to have to put some sort of padding in between each of these members, because on top of the type and the data, there's going to be some metadata, there's going to be some other peripheral information or gaps that you need to fill in, so that once everything gets decoded, everything aligns properly and fits into sort of what you can think of as like slots. So what I mean by that specifically is, when I was getting the data back, when I was very close to having the right format, but before I introduced these padding pieces in here, is I found that there were a lot of gaps showing up in the data. So what I was seeing is, I would see archive ID, for example, here, and then I would see created on be empty. And then I would see in the next element, I would see archive ID being empty, and then created on being filled in, but with this instances created on. So there was a lot of misalignment happening in the data, because technically the chat message inside of the class in JavaScript is not the same data member as a struct object inside of Rust, right? And the way that they're allocated in memory is not going to be the same either. So we are attempting to simulate the data structure as it is presented from Rust, even though we're working inside of JavaScript. Okay? So sequence is just another way of saying array. So my guess was that since I know the binary data, the byte array data is of U8s coming in from either coming into or coming out of Rust, I figured I'd try that as an element of this array. It's basically an array. And then I would make it 2 elements long and play with that. First I tried like 3 or 4, and then I got it down to 2, and that seemed to fit. Everything seemed to align. So then that's the struct itself, right? This guy itself. But again, we have an array of these structs coming back. So I need to create that array, and then I need to give it the same length, right? And we'll get into what this looks like. And then once I do that, I have this LO object that I can use to call the decode on the real data. And then I send back. And this any is coming from the decode because there's no TypeScript enabled for buffer layout. So that's why I keep saying that it's any, but it is type array of chat messages. So then this guy right here is just length 20 because arbitrarily, for testing purposes, we decided we're only going to use this much data, right? Obviously, it would be different for your records, your schema, whatever that may be. All right, so the same thing for this guy, but for the other account instead. Then we take this data and we clean it up, and then we turn it into a different type so that our views can digest them more easily. What is going on here? So this took me a really long time to figure out because, like I said, there's no documentation for this alignment business. But what I found is there were all sorts of extraneous values like this Unicode character coming in. You see right here all of this stuff. Sometimes I was getting plus signs, stuff like that, as I was playing with it and trying different things. So this was an attempt to clean up the actual member values. And then after that, I was getting some records that were just bizarre and just that I never inserted, that were just, showing up usually on the first index. So I'm trying to clean that up here and filtering out for those kinds of records. This just says, if the values are all 0, then I don't want that particular record. So then, once I accomplish that, like I said before, we're not going to go to Solana to get the actual data. We're going to go to Arweave. So I created an Arweave service, right? Again, all the Arweave stuff is in the Arweave folder, and it's called Get Data. But before we go through this, let's go through some of the initialization in here. So first of all, I created this, let's see here. Yeah. So I created this class to represent the container for our data. So this is the actual message that I'm sending, and then this is that string of milliseconds. Probably in this case we don't need this because all the transactions do have a timestamp, but just to keep things consistent and easy, I just put it in there. So I decided to contain all the related Arweave code in this single service class. And the way that initialization works is we need to call the Arweave class instance. And this is the regular SDK, not the test SDK. Those are two different things. So when we initialize in a similar way to Solana, we need to indicate which network we're pointing to, some other important information like the port number of our URL and the protocol that we're going to be on. So HTTP as opposed to, say, for example, HTTPS. So then on top of that, because we're in a test environment, we need to initialize the test weave, which will give us our testing wallet and our testing wallet key effectively. Okay, and then I'll explain the save once we get there, but for now let's explain how to get data. So this thing is going to take our decoded array of chat messages that are coming in from Solana. Again, each of these is going to have the archive ID, which is a transaction ID within Arweave. So we're going to loop through these chat messages. We're going to get each individual message, and then we're going to call this Arweave transaction get data call, and we're going to call it with the archive ID. Okay, and then we're going to get back the message, we're going to decode it, and we're going to claim that it's a string because that's how I entered it into. So we're going to get back a string, and I have to manually convert it to a string because it's possible to be a uint8 array as well. So then once I get it back, I set this Arweave data object with the appropriate fields, and then I keep looping the next one until I'm done. So once I get back the data in the Arweave data format, I now have to convert it into this format so I can send it into my views so that they can digest it. Right? So I map it, I convert it, and then I return it. So once I do that right here, this is an asynchronous call, so I use my callback, and then I set it to these one of these two guys. So remember, this is the prop type that I'm going to use to send into my view. So just to show you, message view is this section right here. So that's what I'm passing it down to. And in this case, I'm just merging them together because I'm going to filter and sort and stuff in here. Okay. So in here, this is my actual messages view. This guy right here. I don't know why this isn't working, but this is the actual view. It takes in the props. These are the props right here. And then whenever these props change, it runs this code that's going to first sort by the created on, right? After removing these whatever extraneous characters. And then it's going to map and convert these into actual individual chat elements, right? So for every sorted chat message, there's going to be one panel element per. So the ones that this person sent show up here, and the ones that this person received show up here, and then on the other screen it would be flipped around. So that's what this guy here is doing. So then if we look at this view inside the views, we can see that it receives props that are basically the same, but also indicate whether it was sent or received. So if sent is false, then that means it was received. So inside of here, what am I doing? So I am cleaning up, again, some of the created on values, right? While I was testing and stuff, I was having some issues. So it was just quicker to eliminate erroneous values that I had accidentally inserted into the type. So that's what this is about. You don't, unless you're making mistakes, you don't need to have this in your code. And then here, I am converting the milliseconds into an actual number type, and then converting that into a JavaScript date using this format. So you can also see the timestamp as well as the date. And then I want to indicate stylistically whether this is a received or a sent message. So I have styles that if it's a sent message, then it'll push to the right-hand side. If it's a received message, it'll pull to the left-hand side. So that this little mini logic figures that out. And then you have the view. So this is the call that we saw before, and I figured it made sense to put it inside of this view since the output is specific to this view. Okay, so then, what's the other main piece? The other main piece is sending of messages. So that's represented by this UI. So when after the message is typed and then the person clicks submit, what's going to happen? Once they click submit, they're going to save the actual message, just a string, right? This is the real message that appears down here. So they're going to save it, assuming this save into Arweave was successful. They get a TX ID and then a transaction ID from Arweave. And then that transaction ID is going to be saved into Solana, so it can be a shortcut pointer back to Arweave. right? And in previous videos, I showed you how to do this already. So let's just look at how to save into Arweave. So into Arweave, we're taking our message. We are creating a transaction with this call right here. So a transaction is basically, or the data of a transaction is basically anything. So in that sense, it's a lot like the data type inside of an account in Solana, except you can deliberately say that this is text, or in my case, text, or you can say it's JSON or whatever by adding this tag, but it can also be binary data. So I take that, I identify with this content type, just like in web development. And then just like in Solana, I have my current wallet sign it, which is my test wallet, right? Because somebody has to pay for the transactions. And then once it's signed, then I can attempt a post, which is to save the transactions inside of Arweave. And then this is only for testing purposes. We want to force a mine operation to happen, meaning we want the block to be mined and inserted into the chain validly. If this was happening on the regular, the production mainnet for Arweave, there is no such call. We simply have to wait for the block times to finish and this transaction to be posted, right? So you could put in a timer or whatever you want in here to have a delay. And then once that's done, we want to get the status of it because we want to confirm that, it was successful. So another way to handle this in production might be to put it into a loop. Although I would caution against making it an infinite loop. I would probably say do a loop with a maximum number of retries. So then this guy will come back, and then let's say that it takes a few seconds. So the first few tries, the status is not 200, because all these statuses are the same statuses as in web calls, like 400, 200, 403, stuff like that. So you want to check what the status is, and then when the status is equal to 200, then you can exit and return the ID of the transaction, right? And as I said before, that transaction ID gets saved into Solana, the account, by the smart contract that we created. In Solana, smart contracts don't have state, so you're not saving anything into the smart contract. You're saving it into the account that the smart contract has access to. So in here, okay, we're just calling the get messages internal, but with this wrapper, and I was sharing it with this guy. All right, so let's see what else we could take a look at. So we don't need to look at the wallet because we covered most of that in the other videos. Let's see, in here, again, super important. Once you compile and then deploy your smart contract into whichever cluster you're running, you need to come in here and update the program ID into here. Otherwise, you'll be pointing to my smart contract, which obviously won't work. So here, Okay, this is the old code from our previous video. I'm not going to bother with that. This is the code we just covered before about creating a new chatting account. We covered most of this code already. I think I covered this, but if I didn't, just to drive the point home, these guys are here because when you send the message to Solana, the TXID, we need to make sure that the archive ID's actual value and the created on actual value has a length that is correct for the sizes that we selected in our dummy values, right? So the length must be the same as these, which is 16 for created on, 43 for the Arweave transaction ID. And then if for some reason they're shorter then they need to be filled in with extra zeros. That's my placeholder dummy values. You can use underscore, pipe, whatever you want, but that's what I chose. And then so these functions are attempting to recognize a shortness of the length and then filling in zeros as appropriate and then returning that fully filled in value so that we won't have any issues deserializing or serializing. So that's what that's about. And then we create our Solana instruction. We take that object, that new single message object, we serialize it, we stick it in a buffer, a blob, and we send it ultimately to Solana. And then similar to Arweave, we're basically checking how that went and then returning the result. So really that's about it. So as you saw, these serialization, deserialization, this business is definitely not trivial. And I suspect that if you have more sophisticated, complicated schema, right? Other types of values, you're going to run into your own issues. If you really find that you're stuck with your particular data type, I would consider converting it to a string like I did to make things a little bit easier, because since you have total control of this code, you're able to recognize what the data type should be. And then upon the deserialization, you can hydrate back into the proper format that you need to work in a type safe way. So I wouldn't spend too much time trying to wrestle with the serializers, because at the end of the day, they're not really the main work of your app and of your program. It's all the other stuff around it, right? So if you end up getting stuck like that, my recommendation is to either go with strings or maybe even with JSON strings if you prefer, and just deal with that instead. What else can I say? Yeah, I think that's it. So as usual, if you have issues, leave a question on the comments. If you have better ways of doing, either some of this for the decoding or some of the other serialization, definitely let us know in the comments so that the other guys can benefit from your knowledge. And again, my next series of videos is probably going to be coming out on the Solana channel. So be on the lookout for that. And thanks for watching. I'll see you next time.